So this question was asked in GATE 2017 Electronics and Communication Engineering paper set 1. You have given that binary phase shift keying waveforms. One is u of 0t and one is u of 1t. U of 0t is given as 5 cos 20,000 pi t and u of 1t is given as 5 cos 22,000 pi t. And both signals are lying between only 0 to capital T, where t is the bit duration interval. Now, you have given that u of 0t, u of 1t are uncorrelated, then you need to find out the smallest positive value of capital T in millisecond. So the NPTEL reference for this question is Principle of Communication System by Professor Aditya Jagannatham. You can find reference in lecture number 15, which is Introduction to Frequency Shift Keying. So the useful data for this question is in FSK, the two waveforms, one is P1 of t is given as 2 over t cos of 2 pi f1t, where t is from 0 to capital T. T is your bit interval. And P of 2t is given as square root of 2 over t cos of 2 pi f2t. So these two are the different frequency, one is f1 and one is f2, and this signal is also live from 0 to capital T. Also, the f1 is given by k1 upon t and f2 is given by k2 upon t. K1 and k2 are the integer values. So your t becomes k1 over f1 or k2 over f2. This is the first useful data. The second useful data is that it is a unit energy. That is, energy in the each pulses is equal to 1. That is, integration from minus infinity to infinity p1 square of t dt equal to 1. Also, in the second waveform, the energy is also equal to 1. So both pulses are unit energy. Now, the third most useful data for this question is that is orthogonal condition. That is, from minus infinity to infinity, p1 of t into p2 of t equal to 0. This is your condition for uncorrelated or orthogonal condition. So one orthogonal condition is also by solving this equation can be written as f2 minus f1 equal to 1 over 2 times 2b. So this is also condition for uncorrelation or orthogonality. Now coming to the solution, you have given u of 0 of t as 5 cos 20,000 pi t and the u1 of t as given as 5 cos 22,000 pi t. Both signal are live from 0 to capital T. Now, for uncorrelated, you need to solve this equation. So, when you put P1 of t and P2 of t in this integral and changing the integration limit from 0 to t, because your P1 of t and P2 of t is lying from only 0 to capital T, and by putting this you will get 25 times cos of 20,000 pi t into cos of 22,000 pi t dt equal to 0, or by using cos of a into cos of b as cos of a plus b plus cos of a minus b upon 2, you can further write this integral. You can write this integral as 0 to t 25 by 2 into cos of 2000 pi t plus cos of 42,000 pi t dt. Now when you integrate this, you will get, and by putting the limit, you will get 25 over 2 sine 2000 pi t upon 2000 pi plus 25 over 2 sine 42,000 pi t upon 42,000 pi is equal to 0. This is also equal to 0. So when this equation becomes 0, that implies your sine 2000 pi t equal to 0, which will give you 2000 pi t equal to 5, or t equal to 1 over 2000. And at t equal to 1 by 2000, this term will also 0. So this equation will be 0 for t equal to 1 over 2000, which implies t equal to 0.5 millisecond. So the answer for this question is 0.5 millisecond. Also, you can solve this question by direct formula, which is given in the useful slide as f2 minus f1 equal to 1 over 2 times tb, where tb is your bit duration. So you will get tb equal to 1 over 2 times f2 minus f1, and this is your 1 over 2 into 1000, that is difference of f2 minus f1, and it is also become 0.5 millisecond. So the correct answer for this question is option B.